In this and the next several videos, we're going to take a look at the source code for the Tip Calculator app. Now, rather than build every line of source code from scratch, I'm going to show you the complete class definition and walk you through the code that's there, explaining what it does and why we chose to implement things certain ways. Now, the source code for the app is stored in the source node of your Tip Calculator project. I'm going to go ahead and expand that node, and you can see underneath here I have the package name that I specified when I first created the app, and automatically the project created tipcalculator.java because when I set up the app, I explicitly stated that I wanted to create an activity called Tip Calculator. And just to refresh you on that, if I select File, New, Other, and go to Android Project, you'll see here the dialog that we first introduced to you when we set up the Tip Calculator project, and down here we had this checkbox that said Create Activity, and we named that Tip Calculator, which caused the IDE or the ADT plugin in particular to create the tipcalculator.java file. And if I open that file up, within that file it automatically created the class Tip Calculator that extended activity, and it did one other thing for me, which was to override this method named onCreate and to also put in lines 38 and 39 in my source code as well. Now, I'll talk about onCreate in a subsequent video, but basically the onCreate method gets called when your activity, when your app first gets launched and starts executing. It also gets called in a couple of other scenarios as well. Now, you'll notice here that I have line numbers displayed in the IDE. That is not going to happen for you by default. You can set that option by going to Window, Preferences, then expanding the General, Editors, Text Editors node, and you'll notice here we have the checkbox for Show Line Numbers checked in our case. We also have set up the IDE to use 3 space indents for tabs, and we do that in our print publications so that we don't indent as far to the right as we create nested code, and that just allows us to have a couple of extra characters to hopefully prevent some line wraps in our printed books. Most programmers tend to use 4 spaces to represent an indent in their code. Now, another thing I want to point out here is that we go from line 1 to line 3 and line 5 to line 13. In Eclipse, it automatically compresses multi-line comments. So if I click this plus sign, you can see that there's actually 2 lines of comments at the beginning of this source code file that I inserted. And then separately, the import statements are automatically collapsed as well. And if I hover over the plus, you can see it's showing you all of the imports that are actually collapsed at line 5. But I can also click that plus sign to expand the list of imports. And I'll talk about those imports in just a moment. Now, one other thing I want to point out about the import statements in particular is the Eclipse IDE has a nice feature that allows you to automatically organize your imports. So for example, let me just cut out these import statements, and you'll notice I now get a bunch of red squiggly lines and a bunch of X's in this left margin and a bunch of red marks in the right margin. Those are all indicating errors in the code. And all of the errors at the moment are because of the fact that the Eclipse IDE compiles your code in the background, number 1, and number 2, it doesn't know what any of these class names are and interface names are, and in some cases methods are, because of the fact that we just removed all the import statements that the class Tip Calculator depends on. Now, if you hover over any red squiggly line in the IDE, it's going to tell you what the error message is, and it will often give you so-called quick fixes that can help you fix that problem. So for example, the reason it doesn't know what activity is because we did not import the activity class. So if I click this link here, import activity, it will happily place the import statement into the code for me. Now, another feature that's available for dealing with the import statements is the command called Control-Shift-O. So you hold the Control key, the Shift key, and press the letter O at the same time. And what that does is organize your imports. And in the case where it can distinguish what all the imports should be in your code, it will just go ahead and insert them all into the code for you automatically, and it will also organize them. So you notice it bundled together the 2 imports that come from the Android.txt package and the 4 imports that come from the Android.widget package. You'll also notice that they're all in alphabetical order as well. This is just automatically done by the IDE. Now, if you have a class or interface name that's in multiple Android or Java packages, then what it will do is show you a dialog in which you can choose the appropriate import. So if there's any kind of collision of names, you will be forced to make the decision on which import statement to use. So that's just a nice handy feature of the IDE. Now, the key thing in this example is the fact that we have a tip calculator class that extends activity. And by the way, if you hover over any class name from the APIs, then the IDE will automatically show you the documentation for that class. This is assuming that you've installed the documentation, which indeed we had you do when we first set up the IDE for development back in lesson 1. Now, if you move your cursor into that box, it becomes a scrollable window where you can actually look at the complete description of, in this case, the activity class. And by the way, I highly recommend that you spend some time to study the activity class in detail. And the reason is, in this documentation, it talks about the life cycle of an activity. Now, in our app, we have a single activity, and an activity basically represents one screen in an app. So you could have an app with many screens, in which case you'll typically have a corresponding activity for each screen. And as of Android 3.0, they also introduced a concept called fragments. Fragments can live within an activity, and they've actually backported the concept of fragments as well to earlier versions of Android, so you can use them going all the way back to Android 1.6. And basically, a fragment is a portion of an activity, a portion of your graphical user interface. In fact, a fragment doesn't even have to have a user interface associated with it. But the thing that's interesting about a fragment is it can be reusable across many different activities, and in a later lesson we'll get into the concept of fragments in more detail. Now, an activity is your key building block for the moment as you get started with Android development. And an activity basically has a life cycle associated with it that allows the operating system to control it. And activities typically are in one of 3 key states. They're either active, which is an activity that is actively running and visible on the screen and has the focus, meaning the user can interact with the GUI inside the activity. An activity could be paused. So for example, if you're working on a smartphone and a phone call comes in, what will typically happen is you'll wind up with some sort of dialogue on top of your activity, allowing you to choose whether or not you want to answer the call. And of course, if you answer the call, basically what happens at that point is your activity goes into the background, even though it's still running. And that turns it into a so-called paused activity that's still visible and can be brought back to the foreground at a later point. And then finally, we have the concept of a stopped activity, where perhaps the user brings up a different app and your activity is no longer visible on the screen in any way. It's in the background, but paused and stopped activities can be terminated by the operating system in cases when more memory is needed, perhaps to run other apps, for example. If you have both paused and stopped activities, the stopped ones would always be terminated before the paused ones. And then in the activity lifecycle documentation here, actually let's bring this up in the web browser instead. So here is the documentation for class activity. By the way, we're on the reference tab of the developer.android.com site, and those of you who have learned Java previously and worked with the typical Java API documentation will recognize the basic layout of this documentation as well, with your packages in the upper left corner. When you select a package, you get the contents of that package in the lower left corner, and then when you click on any class or interface name, you get the description of that class or interface in the main part of the window. Now, the reason I brought you here is just to show you briefly this diagram, which gives you the kind of life cycle for an activity. You can see that when an activity starts, it calls on create, and then we have this whole life cycle of other methods that can be called for various situations. But right now we're talking about this concept of paused and stopped apps. So when you have a running activity and something else comes in front of that activity, the apps on pause method gets called, which basically kind of puts the app into the background, although it's still visible on the screen, maybe because, again, there's a dialog on top of it. If the app is no longer visible, its stop method gets called as well, and that stops the app from executing. This is where you might, for example, in on pause and on stop, do things like terminate various threads in your app. But more importantly here, you can see that from on pause and on stop, if the activity gets killed, then we're going to eventually have an on create call again. And throughout the next many lessons, as we introduce various activity methods, we'll discuss more and more about the life cycle concepts just as we need them. If you want to get a detailed discussion of the life cycle of an activity before you continue, then what you'll want to do is come to this online documentation for the activity class and read the class overview in detail as it describes for you the complete activity life cycle and why all the different methods of class activity will be called and what scenarios in which they'll get called as well. Now, in the next video, we'll start talking about the activity class tip calculator in more detail.